Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. My name's Alison Stewart and I'm your host of this session of Cut the Crop. And today we have FAR researcher Matilda Gunnarsson. Hi, Matilda.
Hi.
And we have Lincoln University lecturer in arable crop production, Pieter-Willem Hendriks. Hello.
Pleased to meet you again.
Yes. And so at ARIA, you were giving a presentation on crop competition to manage weeds. And so let's just talk about that, but maybe start off with you, Matilda, and talk about just like the high level issues around weeds, because they are, a big deal for arable growers. And then we'll drill down into the crop competition side of things. So why are weeds in crops such a big problem globally?
Well, first of all, they compete with our crops for nutrients, water and space, all three things that our crops want and need. And we know from global numbers that 35% weeds are estimated to cause sort of 35% yield losses globally. People have tried to look at that number here in New Zealand as well, and it's not quite as high, but it sort of sits around the 25%. But the more resistance we have, that number is going to increase as well. So, but there's other things like if we want to export seed crops, there can be certain markets that won't take our seed if we had a certain weed in it. So it's about market access as well. Yes.
So you mentioned resistance, obviously to ag chem. That's becoming increasingly a much bigger problem. Let's just talk about sort of that as an issue, because we know overseas, that there are big problems, and we know that in New Zealand that we're experiencing increasing problems.
Yes, we do. So for the last 5 years, FAR together with AgResearch have done extensive crop surveillance program across the arable sector in New Zealand. And we started off with 14 weeds that were resistant to New Zealand 5 years ago, and we now have 21. So we found 7 new species while we did that. I would say that that's not the main concern that we found. The main concern is actually the frequency of resistance on farms. If we look at ryegrass, for example, some arable cropping areas in New Zealand, 50% of the farms have ryegrass resistant to group 1s and 2s, and they are the post-emergence herbicides we use to control grass and cereal. So it's real serious, and we are seeing in those areas where the problem is most serious, we have short cropping rotations and we grow lots of ryegrass for seed crops in those. So areas that have more options have less resistance.
Yeah. And we're not getting lots of new, chemistry coming down the pipeline. And so it's one of those things in the past that if you had a problem with one, ag chem, there was another one coming along and you just replaced. But now we've got a certain amount and that is not going to increase too much. And so you've got to really protect the performance of the existing chemicals that we've got.
Certainly. And I mean, there is actives out there that control ryegrass in particular that we don't have. They do have them in Australia, but they have resistance to them. So just because we might get new actives doesn't mean that it's going to be better. And also they are not discovered very often anymore. It's just the reality. We're not going to have more actives coming anytime soon. And also, New Zealand is a very little market, so chemical companies doesn't necessarily want to register their actives here because they can go to bigger markets and have a better return on investment. So we have to look at the options. Chemicals have served us really well for many, many years, but they will we're not going to farm without them, but we're going to have to farm with other options as well. Otherwise, we're not going to control our weeds.
Yeah. And I think that, that's the same story with fungicides and with insecticides as well, is that, people recognise now that a chemical-only sort of crop protection programme, sort of in the short term, and I talk short term, 50 years, has actually worked really well, but we're now in a situation where we're not going to be able to continue to manage, those pests and weeds and diseases with just one. There is no silver bullet now. So there are now a whole range of different options that we're going to have to look at to see how growers can, maintain productivity with a number of different integrated sort of, crop protection systems. And one of them that you were both talking about at ARIA was using crop competition to manage weeds. So let's just talk about that in a little bit more detail, Peter.
So yeah, thank you. Crop competition has this advantage that is easy to apply on a farm. So farmers don't have to invest in new machineries. They don't have to learn new practices. So therefore, it is an easy to apply and relatively economically easy to apply solution as one of the integrated managements. As you said, there's no silver bullet. It comes in a package. You want to look at other things at the same time, because weeds are constantly adapting to the different systems that we use. So the more different techniques you use, the better. But the integrated weed management through crop competition is probably one of the easiest to access.
So what does it mean? Like, how do you actually implement this in practice?
Okay, so if you look at competition between plants, you have two major sides of competition. Above ground, mainly about light. So the faster you shade out your competitor, the more gain you will have in growth, specifically early on in the growth stages. So a crop that will close its canopy faster will be more competitive against weeds. Below ground, we're looking at interception of water and nutrients, and therefore a vigorously growing root system, one that spreads into the soil volume quickly, will be very important to foster.
So you've had experience in this when you were in Australia. So talk about the work that you did in Australia and the kind of results that you got.
That was part of a team. I was very lucky to join a team at CSIRO under Greg Rubetsky. And Dr. Rubetsky had been breeding more competitive crops for more than 2 decades. And that was an effort by taking the most competitive wheat varieties around the world and just randomly crossing them and then scoring them for leaf width and leaf length, which are an indication of how fast the canopy would be closed by those wheat plants. And he managed in 20 years to double the size of the leaves, of the early leaves, through recurrent selection. So by taking the 10 best percent, crossing them again, tossing all the rest out. So very hard work. But then you end up with a plant that is quite it is almost a monster plant. It has no agricultural reality to it. So he then tested the feasibility of taking that figure for the most extreme ones and putting it into commercial cultivars and see what happens. And that was very successful. So my work was around looking at those commercial cultivars that had been increased for vigor, compared them to other crops in Australia, both above, but mainly with a focus below ground.
Okay. And so if I'm an arable grower, my first question will be, was there a yield penalty?
That's funny. It's always the first question that we get, and it makes sense. So coming from a farmer background, I fully understand that question. So actually, very interestingly, everybody was expecting that in times of drought, we would have a serious cutback because these plants grow more vigorously in the beginning specifically. So you would expect they would suck out water out of the system. And in places like Australia where less irrigation is available, this might be a real issue if you don't have water in the reserve in the soil anymore. Out of the 4 field experiments that we had in different locations in Australia, irrigated and non-irrigated, only 1 field trial had a significant yield penalty. So that means that there are options to improve this while maintaining your yield.
Okay, so how is that working? Like, what was the underlying reason for that?
That would be a full other PhD to be done. But my first guess would be is that these root systems underneath these vigorous plants are also much more vigorous, and they're capable of chasing water much deeper into the soil profile. So specifically in Australian context, every centimeter you gain growing downwards is a gain in yield because you have access to water volumes that weren't available beforehand. So I think that's how they achieved being more vigorous while maintaining their yield.
Okay. But I mean, obviously New Zealand is quite a different situation to Australia. So how is this going to play out in a New Zealand context?
So in a New Zealand context, I'm suspecting that because you have access to water, that problem of yield penalty due to early water consumption is going to be much less of an issue. I think that the opportunities here are even bigger than in Australia to look for competitive crops.
So you're involved in a project in New Zealand looking at light interception. So let's just talk about that in a little bit more detail.
Okay. Thanks to Matilda, I was involved with the field trials that you have in Rakaya. And we decided that we would look at light interception of those crops as a first attempt to see if there's any variability between your different cultivars about that. And very interestingly, of the 12 lines that are out there. I think it was 12, yeah. Yep. Out of the 12 lines out there, you have lines that are closing the canopy much faster than others, specifically in that early stage where you want to make sure that your plants are more competitive.
Yeah. But you haven't got any trials out there that are actually looking at weed control at the same time? Are you just looking at light interception as sort of as an attribute in isolation at the moment? You're not looking at weeds?
No, so we actually sort of just tapped on the CPT trial. So we've just done light interception and that. So, but the aim is to take the results from this year and then do our own trial next year and look at weed competition as well, because those CPT trials have had the management of their farmer paddocks. So there was no difference in.
So how do you measure light interception?
Well, I borrowed one of your tools. We use a septometer, so it looks at the photosynthetic active radiation. To be a bit technical, it's the light that actually the plant can use to do the photosynthesis. You measure it above the canopy, and then you measure it below the canopy. You do that several spots per plot, and then because you have reps, you can get statistically significant or insignificant differences, but at least it has a value to it. So we do this through the whole growth from early sowing all the way to canopy closure, because once the canopy is closed, you will have near 90% interception anywhere. Yeah. It's more to see which one of these crops is getting there faster, because that will be a more competitive crop above ground.
And obviously you have to be using cultivars that are commercial cultivars that the growers know that they can, sell, and that they meet all of the attributes of the market, whether it's, feed or sort of milling wheat or whatever. Have you seen examples overseas where people are actually using this management practice as part of their integrated weed management program? Or is this completely sort of new?
So yes, there's a Swedish company who is now selling at least 2 varieties as these are more competitive varieties. And they aimed for below ground competition as a key for that commercial product. Because as I said, below ground competition starts earlier and is actually more intense than above ground. Plants will be competing for water and nutrients way earlier than they will be competing for light. And one of the ways of a plant to outcompete one of its competitors below ground is by emitting molecules that will slow down or stop the growth of the competitor. So that phenomenon is called allelopathy. And one of the historical examples is all the walnuts. But other crops do that too. Sorghum is very famous for it. Your rye corn is one of the best winter crops to actually outcompete weeds by emitting those molecules, but wheat does that too. And in Sweden, they have 2 varieties that are more allelopathic.
Yeah, actually, it's interesting because I was actually thinking about exactly that, because in the past, a lot of people did companion cropping, and one of the problems was that they always found that one grew better than the other, and it was because of an allelopathic effect. And so that was a negative, but this is actually a positive. So as far, I'm looking at Matilda now, I mean, our growers might listen to this and say, oh gosh, this is a little bit too futuristic for us. But the reality is that we have to be looking at all of these different options. And so what are the range of things that we're going to be looking at as potential alternatives to herbicides as part of this bigger weed management program that FAR's running?
In the ground this season, we have a couple of different. We've got a mechanical weeding trial, so we have used a tine weeder. So that's one option to do mechanical control. We also have a trial at Chertsey where we're looking at increased sowing rates and different row spacings, just to look at that. Can we get canopy closure earlier by growing our crop in a more narrow row? What else are we looking at? And then I guess it is, we're not doing that currently, but it's looking at what rotations, not only what cultivars are more competitive, what crops are more competitive. We know barley is way more competitive than wheat. Spring barley comes out of the ground and just is very vigorous. It's a really good crop to grow. It's been a major solution for growers in the UK when it comes to controlling blackgrass.
If we got blackgrass, then, and in some ways, watching what the growers overseas are doing to manage blackgrass gives us a bit of an insight into how effective some of these alternative options are being. Like when Rob Waterstone was talking about what he was doing, a lot of it was linked to his rotation as a means to keep the blackgrass seed bank lower. And so we can piggyback on a lot of that and make sure that we keep blackgrass out.
The longer we can keep it out, the better.
This is not going to be a short-term fix. This is literally going to be, sort of an ongoing process of learning just how to live with a certain weed population and keep it below a threshold that would start impacting on major yield problems.
Yeah. And I mean, when it comes to resistance, it is a numbers game. The more weeds we have, the more likely there is to be seeds with the mutation. So we do want to keep the numbers down. But we just need to find a range of tool to do so. We can't rely on one tool to do it for us. And historically, it's been easy with the chemicals. The knowledge is in the can. It's easy. It tells us what to do. But if we're going to change, like as Peter said, that you don't, with crop competition, you actually don't have to invest, and it's not a major shift. But for some of the other, like tine weeding, for example, it will be a learning as you go experience, because you are going to, you need to use the machine to have as most damage on your weed, but as least damage on your crop. And it's going to be just trial and error. And that's something I think we need to accept, that we just need to relearn a little bit and look at old and new tools to control our weeds in the future.
Yep. So what have we got coming up then over the next couple of years in the crop competition space? Are we working with any of the breeding companies to look at their breeding programs to see what's coming through?
Not currently, and we have asked, and I don't think it's necessarily at trait they are looking that closely at the moment, my understanding. But we will certainly take the learnings from this year and see what we can do with it in coming trials.
Yeah, I mean, sort of the breeding area is always challenging because, growers will always want yield to be the number one attribute, but it's got to be yield in the context of a very sort of changeable environment. And I think that attributes other than yield are going to increasingly come in. I think pest and disease tolerance, and then these physical attributes. I think that they are. I mean, it just takes time, unless of course we got advanced breeding technologies coming into New Zealand. But we won't get into that. Anyway, any final comments, Peter, from you?
I think Matilda made a very fair point. Is that like you would rotate your crops, you need to rotate your chemicals, but you also need to rotate your integrated weed management strategies. Like, don't fixate, for example, if you buy this new twine machine, which is of course expensive, and you want to use it as much as you can on the farm, I would be very careful of relying on a single system. As you said, there's no silver bullet, but we also found out the weeds are very adaptable, much more than we are or our crops are. So if you rely on a single system, you will get into a form of tolerance or resistance to that system quite quickly. So I would suggest make sure that you rotate through your solutions as well. And looking at integrated management is not saying bye-bye to chemicals. It's actually, the goal is that the chemicals that we do have, we actually extend the life expectancy as long as we can, because at $500 million to produce a new product, Matilda already mentioned, you're not going to get that many new products on the market.
Yeah. I mean, it's just frustrating because, arable farms are already quite complex, and our message now to our growers is it's going to be even more complex.
In our case, it's actually a friend and not an enemy.
Yeah, that's right. And in some ways, that is the message, is to embrace it, because, you look at a lot of other sectors in New Zealand, that actual monoculture-based sectors, and from a resilience point of view, they are more at risk, than, for example, an arable system where you have got that diversity and that complexity. It just means that our growers have not 101 different things to think about, but probably 201 things to think about. And that's what FAR and other research institutes are here to do, is to try and support them in introducing that integration of different systems. So thank you very much, Peter and Matilda. And I'm sure we'll hear more about FAR's weed management programme over the next couple of years as we invest more and more of our resources into that. And thank you very much, listeners. Have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.